Professor in physics and chemistry, Gay-Lussac's law is named after the chemist Joseph Louis Gay-Lussac. He was fascinated in the different properties of gases back in 1801, where he claimed that equal volumes of gases expand equally with the constant rise of temperature. This was also called the Charles Law. It was an homage to Jacques Charles, who discovered it first but wasn't able to publish it. Additionally, with his interest in hot air balloons, the Gay-Lussac law was his first initiative. When Gay-Lussac with his friend John Baptiste Biot rode this hot air balloon, they were studying about the Earth's magnetic field. But soon after, Gay-Lussac observed that as they were going higher and higher, the pressure or the energy between gas molecules is becoming weaker and weaker. At the same time, the temperature is becoming lower. After this event, during his European tour, he continued to study about the properties of gases, hence he named it the Gay-Lussac's law.
The things that you need for this experiment is a lab apron or coat, but it is only optional. A shallow dish, a medium-sized candle, a clear glass or jar, or even a beaker, some water, food coloring. You can use any color of your choice. In this case, I chose the color red. And lastly, matches. First, you have to fill the shallow dish with 1 to 1.5 inches of water. Then, add 3 to 5 drops of food coloring. We are doing this in order to be able to see the water. Afterwards, place the candle in the middle of the shallow dish. Light the candle using the match. Take the jar or the beaker and place it on top of the candle. Watch and observe. As we can see, the flame has extinguished and the water level rises, which is higher than the water level on the shallow dish.
The Gay-Lussac's law states that the increase in temperature is directly proportional to the increase in pressure, with volume and quantity remaining constant. In this experiment, the candle is lit and after a few minutes, it will eventually extinguish. As oxygen enclosed in the jar is moving around, it is being absorbed by the flame of the candle and turning them into carbon dioxide. This process repeats itself until there is no more oxygen left in the jar. This eventually will lead to the extinguishing of the fire. After a while, the flame has created a high temperature inside the glass jar since the fire continuously sucks in the oxygen until there is no more. The energy of the fire transfers its energy to the oxygen atoms inside the jar, causing it to move faster and faster. This results in high amounts of pressure. Thus, some oxygen is used in combustion to keep the fire burning. Using the Gay-Lussac's law, we can say that inside there is a direct proportional amount of pressure with the temperature. Hence, the pressure is high as well. This fire generates new gas molecules called carbon dioxide and water vapor. Since hotter rises, the carbon dioxide and water vapor rises up to the top of the jar, pushing the oxygen down. As the energy inside the gas molecules starts to diminish, the pressure inside is continuously decreasing until it is lower than the pressure outside. Since the air pressure outside is higher than the pressure inside, it would want to be equal with the air inside the jar. Hence, the air molecules from the outside will force themselves through the bottom of the jar, creating equal amounts of pressure. With the push of air molecules going inside the jar, the water goes up with it, creating a higher water level compared to the outside. The water level only then stops rising if the pressure of gas molecules inside is equal to the outside. And that is the Gay-Lussac's law.